In this in-class exercise, as you can see, we have a whole bunch of structures drawn. And I've just given you one question to answer here that applies to all of these structures. For each of these compounds, are they aromatic, are they anti-aromatic, or do they qualify for neither? In order to do that, we should briefly review our rules. For a compound to be aromatic or anti-aromatic, it needs to be a planar ring fully conjugated, and if it's aromatic, we should have 4n plus 2 pi electrons. And if it's anti-aromatic, we should have 4n pi electrons. So what we'll do here is we'll highlight the aromatic ones in yellow, the anti-aromatic ones in purple, and we'll use green for neither. Now, typically the ones that are neither are the easiest to identify. Because if we look at a compound like this one here, notice we have a carbon in that second ring, in the 5-membered ring, that's sp3. Because we have that sp3 carbon, that means it's not fully conjugated, or even more importantly, it's not planar. So if we go through any of these rings and carbons that are not sp3 hybridized, we can immediately identify those as neither. So if you notice, each one of those compounds that I've highlighted has at least one carbon, well, in this case it's all of them, but has at least one carbon that's sp3, which means that the ring is not planar. And if it's not planar, it cannot be aromatic or anti-aromatic. The rest of these compounds are all fully conjugated and are planar. So it becomes a matter of then counting the number of pi electrons in each of these compounds. So starting here with our first one, so we're going to do that, and then we'll go back and identify as aromatic or anti-aromatic. So 1, 2, 3, 4, 7, 8, 9, 10, 11 pi bonds in that structure. So we have a total of 22 pi electrons. The next compound has 2 pi bonds for 4, and then there can be 2 electrons from the lone pair on oxygen for a total of 6. Our next compound has the lone pair plus 2 from the negative charge is 4. We go down here, we're just counting pi bonds. 5, 6, 7, 8, 9, 10. That's a total of 20 electrons. Same thing with this structure, we're just going to be counting the pi bonds. 5, 6, we have a total of 7 for 14. Down here, this structure containing the nitrogen has 3 pi bonds for 6. Here we've got 1, 2, 3, 4, 5, 6, 7, 8. It's 16. The compound up here containing sulfur, 1, 2, 3, 4 pi bonds, plus the 2 electrons on sulfur give us 10. This compound here with the oxygen is exactly the same as the sulfur, so 10 here as well. Right below that, we have 3 pi bonds plus the negative charge, gives us 8. Here we have a 10-membered ring with 5 pi bonds, or 10 pi electrons. And these last 3, we're just going to count the pi bonds because those plus charges allow us to have those cations can be sp2, but they don't contribute any electrons. So here we have 2, 4, and 6. So now that we've identified all of the electrons, we can assign aromatic or anti-aromatic. We're going to start with the anti-aromatic. So anti-aromatic are going to have a multiple of 4. So 4 electrons makes it anti-aromatic. Here's 4 as well. So does 8. Basically, any multiple of 4 qualifies as an anti-aromatic number. So that would include these, 16 and 20. And that should be all of our anti-aromatic compounds. The aromatic compounds are when we have an even number that's not a multiple of 4. 2, 6, 10, 14, 18, etc. And so that's going to be any of these that I'm now highlighting in yellow. Now, we've got one compound left, this 10-membered ring containing 10 electrons. And looking at that structure, we probably think that that one's aromatic. But hopefully you recall from class that this is one of the weird exceptions. It has 10 electrons, it's fully conjugated, everything's sp2, but yet it comes in as neither. And the reason is because of the shape of this molecule. It's not planar. And recall that that was our other rule for aromaticity, is the compound has to be planar. Because that 10-membered ring cannot adopt a planar conformation, it cannot be aromatic as well.